Okay, now I'm going to do a example of a Lewis dot diagram for an ionic compound, and I'm going to choose the ionic compound of calcium phosphide. Now calcium has a electron dot diagram of this. It's got two valence electrons. Phosphorus has 5 valence electrons. Now, notice it says Ca3. There are 3 Cas. So I have to have all 3 of them. And I have 2 phosphoruses. So what's going to happen is calcium, being a metal, is positive. Phosphorus, being a nonmetal, is negative. So calcium is going to give up its electrons in order to become stable. So calcium will give its 2 electrons to this phosphorus, so that phosphorus now has 7. This calcium can give up its electrons to this phosphorus, so that phosphorus now has 7. But each phosphorus wants to have 8, so this calcium will give up its electrons like that, and then you'll be left with a positive calcium. And since each calcium gave up 2 electrons, you get a charge of positive 2. And the phosphorus each phosphorus gained 3 electrons, so it has a charge of negative 3. But it still has all 8 of its electrons. So I need to basically alternate my calciums and my phosphorus. You need to make sure that you write the charge there so you know what the charge of each atom is. I put brackets around it to separate the ions, but you have to make sure you have a +2, and they have the -3 and the +2 and the -3 and the +2, because those are the charges of the individual ions. And you'll notice that you don't draw it with a phosphorus next to a phosphorus. You have to keep the negatives and the positives separated. You could have drawn it up and down if you wanted to, side to side, as long as you don't have a positive next to a positive or a negative next to a negative. They have to alternate, and that's what forms the crystalline structure of the ionic compound.